Hey guys, and welcome back to This Week in STEM. I'm Steph Eves, and what's our first story of the week this week? Well, it's about spiders. Yeah, the creepy crawlies. 2 new species of peacock spider have been discovered in Australia, giving me 2 more reasons never to go to Australia ever. Now, peacock spiders are teeny tiny little brightly colored spiders that are only about 3 to 7 millimeters long and are known for their very elaborate mating dances. Now, these 2 new peacock spiders were discovered by Madeline Gerard, a grad student over at UC Berkeley. Not only did she discover these spiders, but she gave them adorable little names. And here's what they look like. Now, the little furry arachnid that you're looking at here is Muratus jactatus, or Sparkle Muffin, as he's more affectionately known. His blue and red hued stripes along his abdomen have a very original striping pattern. And this little guy is Muratus skeletus. I'm sorry, my Latin is terrible, but his nickname is Skeletorus, and you can probably guess why. The white markings along his black body strongly resemble a skeleton. Jurgen Otto, the author of the publication, was super stoked to have 2 new spiders to study, and he had this to say. Despite the large number of species we have discovered just in the last few years, I can't help feeling that we may have just scratched the surface of this most exciting group of spiders, and that nature has quite a few more surprises in store. Now that I've seen the picture, I guess they are kind of cute, but still, they give me the heebie-jeebies and the creepy crawlies. Moving on from psychedelic spiders to psychedelic photographs, for the first time ever, scientists have managed to capture light behaving as both a particle and a wave in a photograph, and it looks a little something like this. Now, why is this so important? Well, for those of you that haven't had Physics 101, we know that light behaves as a wave because it's able to bend around objects and fit through apertures of just about any size. Now, different wavelengths yield different colors, which we talked a little bit about last week with that stupid dress and the explanation behind it. You can click on this annotation to see the story. Okay, so light behaves as waves, big deal. Yes, however, thanks to some observations made by a guy that you might have heard of, his name's Albert Einstein, we also know that light behaves as a particle. In 1905, Einstein noticed that when light hits metal, it ejects a stream of electrons. This suggests that light is also made of particles called photons that are bouncing off the electrons a lot like billiard balls. This discovery would eventually earn Einstein a Nobel Prize. Yay, science! Ever since Einstein's discovery, scientists have been unable to observe light behaving as both a particle and a wave simultaneously. Until now. Researchers at the Swiss Federal Institute of Technology in, you guessed it, Switzerland, came up with a brand new technique to help us capture this image. So how do they go about capturing this super psychedelic image? Well, they fire a laser pulse at a teeny tiny metallic nanowire. The laser adds energy to the wire's charged particles, causing them to vibrate very quickly. Now, light waves will start moving along the wire in 2 directions. Now, when 2 waves traveling in opposite directions meet, you get a standing wave, which is what you can see here. At the same time, a stream of electrons is fired alongside the wire, bouncing off the photons and causing the electrons to either speed up or slow down. These changes in speed appear as an exchange of energy packets, or quanta, and show up as the blips seen here. Stick this process under an electron microscope with a super fast camera and you get the image that I've only flashed at you about 4 or 5 times at this point. So can this help in the technological world? Actually, yeah. Actually, this imaging technique could be used to help advance the development of quantum computers, which are super fast computers that take advantage of some of the properties of photons. Thanks to this technology. So at last we see the light. That's right, I made a tangled joke. I regret nothing. Our next story involves Jan Sherman, a 50-year-old quadriplegic who's been working with Darpa to develop some really cool technology. In 2012, Jan decided to give Professor X a run for his money, agreeing to have 2 electrodes implanted on her left motor cortex on her brain. These electrodes allow her to control a robotic arm using only her mind. Now, typically, the left cortex is responsible for the movement of the right side of your body. However, Jan has been able to control both right-handed and left-handed robotic arms. Recently, Jan decided to step her game up and climb inside the cockpit of an F-35 Joint Strike Fighter simulator, where she was able to successfully fly the simulator using only her mind. Now, this is a huge deal, and at the Future of War conference last week in Washington, D.C., DARPA Director Arati Prabhakar spoke very highly of Jan's accomplishments and what exactly they mean for the future of this technology. It's so moving to see what an impact it has on people, to even be able to experiment with a technology like that with the perspective of restoration. In doing this work, we can now see a future where we can free the brain from the limitations of the human body. While this tech is in its infant stages, it has huge growth possibilities. In the future, drone pilots could fly their aircraft remotely using nothing but their mind. This tech is so huge that DARPA isn't the only one looking into it. In fact, a team of researchers in Germany is working on a project called Brainflight, and they've had some really promising preliminary test results. One of their test subjects was able to follow 8 out of 10 target headings with a deviation of only about 10 degrees. Additionally, several subjects successfully managed a landing approach with poor visibility. In fact, one of them was able to land within a few meters of the center line. This tech is incredible, and I can't wait to see how it develops in the future. And now on to the final and what I think is the coolest story of the week. Friday, after multiple program cancellations and then reinstatements, hardware failures that required innovative engineering to fix them, and a 7.5-year, 3.1 billion mile journey, the Dawn spacecraft arrived at Ceres and successfully completed its orbit insertion around the Dwarf planet. Or, as Mark Ryman, the Dawn chief engineer and mission director at JPL put it so poetically,
Ceres reached out and tenderly took the newcomer from Earth into its permanent gravitational embrace.
Yeah, I couldn't have said it better myself. In fact, I'm pretty sure Robert Frost couldn't have said it better himself. Now that Dawn is in orbit around Ceres, it's become the first spacecraft to successfully orbit 2 celestial bodies. It orbited and studied the asteroid Vesta a little over 2 years ago before heading on to Ceres. Additionally, it's the first spacecraft ever to orbit a dwarf planet. Now, why did it take so long to get to Ceres? In order to get to Ceres, which lives in the asteroid belt located between Mars and Jupiter, the engineers designing Dawn's propulsion system opted for the more slow and steady approach. Dawn uses 3 ion engines, which rely on, you guessed it, ions to propel the spacecraft forward. Now, ions are teeny tiny little electrically charged particles, so they don't have a lot of push when it comes to shoving a spacecraft across the solar system. So ion engines are incredibly slow, but incredibly efficient, so they don't require a whole lot of fuel to be hauled around with the spacecraft. So why visit Ceres? Well, a little bit of background information first. Ceres was formed 4.5 billion years ago from the usual suspects, dust and gas, but it must not have eaten its fruit and veggies because it got stuck in a state of arrested development, never really growing beyond the size of about 1/3 of our moon, so it's really small. As a result, it was classified as a dwarf planet like Pluto. Now, scientists do know that initially Ceres had an icy core. What they don't know is what it looks like today. Is it still ice that's frozen solid, or has the planet's radioactivity melted the ice a little bit, causing lakes or even oceans to form underneath the surface of the planet? Now, whenever liquid water comes into the equation, everybody starts asking, could the planet be hospitable to life? And the short answer is, we don't know. Scientists are unsure if Ceres could have ever been habitable towards life, or even if it is today. In fact, Ceres seems to raise a lot more questions than it answers. For example, since late February, Ceres has had us all asking,
What the heck are those 2 blips of light in that crater on the surface?
Now there's a lot of theories being thrown around. Could it be ice that was uncovered by an asteroid striking the surface? Or could it be the sheen of minerals reflecting back that were deposited from geyser eruptions? I personally have my own theory, which I think is equally likely and that we should all be very worried about. Okay, maybe not, but a girl can dream, right? Now Dawn is behind Ceres, and we won't be getting any picture data from her until late April. On April 23rd, Dawn is set to begin her first scientific orbit at an altitude of approximately 8,400 miles. Now eventually, Dawn is set to drop down to an altitude of about 230 miles, so she's going to get a lot closer. During her mission, Dawn will be mapping the surface of Ceres, analyzing chemical composition, and estimating the planet's mass. The mission is expected to go until 2016, and scientists are already thinking they're going to get more data than they had initially anticipated. So I don't know about you guys, but I am super excited about this. It's going on my calendar right before the Age of Ultron release in May. Something else to look forward to. So that's it, guys. That's what happened this week in STEM news. If you guys want to go back and recap any of the stories that I covered this week, I'll go ahead and be sticking annotations here-ish, so you can go back and review them, show them to your friends. If you like sciencey stuff like the stuff I covered here, or you just think I have a really great personality, feel free to give the video a big thumbs up and subscribe to the channel. And then go ahead and check out last week's TWISTEM video. I'll put an annotation right here so you can check it out. Don't forget, if you got any really cool STEM news stories this week, feel free to tweet them at me at @StepFeds43 on Twitter. Look out for a video Wednesday. I think I'm going to start dropping videos in the middle of the week about different topics, things I want to talk about, stuff people have tweeted at me to talk about. So stay tuned for that. It'll probably be kind of a grab bag at first, but I'm excited about it, so look out for that. And with that, I hope you guys have a super awesome week. And don't forget to share this video with your friends and your family and your dog. Every view counts. I just want to spread a little STEM love throughout the world. So thanks for watching, guys, and I'll see you next week. And Peacock. And Kiki were discovered by, what is her name? Oh, he has an itch and I can hear it. I don't know if you can hear it, but I can hear it. Are you done scratching? Excellent. Maybe not. It's a metal what? Metal surface. Photons. And Listen. Why is my voice going up that high? That's like, ooh. Ever since sorry, Albert. Well, they fire laser pulse at a teeny tiny metallic. Oh, God. Oh. Now, when two shut up, don't bark. Now, Loki, don't bark. Manages some of the properties of photons. Shut up! I had that nailed in your crap head. Ah! I had it. You barked, jerk. Don't stop barking. We're not gonna be friends for 5 minutes. You're killing me, Smalls. Week in Washington, D.C. Why did I totally just forget the nation's capital city? Dude, fixing a window. How are you gonna do fixing a window? Where's your job today? In fact, a team of research. Successfully, I said space crap. That's a thing that happened, and I hate myself for it. I said space crap. Hardwell. Chemical combination. Yay, science!